Good morning, ladies and gentlemen. Good morning, those of us who are online and those who are in the audience. We had a slight delay, apologies for that. And so, with us this morning is Professor Jorge Colõn, and this is part of our chemistry department's. It's because of collaboration. It's part of our chemistry department seminar series. And this also is one of the sessions for the UN General Assembly Science Summit. So this is really an amazing opportunity that we all have to learn and to have this session take place. And so I am going to turn right over to Professor Jorge Colõn, who is going to be introducing the speaker for this morning, who is Professor Victor Castaño. So I'm going to hand over right to you, Professor Colõn. Good to have you with us,
Thank you. Thank you, Dr. Gallimore. I want to add also that I am part of the Greater Caribbean Light Source LAMISTAD team and member of its capacity building subcommittee that is headed by Professor Marbadin Singh Wilmot. And this subcommittee is the one leading this Beyond Beings webinar series. But it's my pleasure today to introduce a speaker, Dr. Victor Castaño. Dr. Castaño is a professor of applied physics and coordinator of prospective and strategic projects, Secretariat of Institutional Development at the National Autonomous University of Mexico, the UNAM, in Mexico City, Mexico. He's also coordinator of the multidisciplinary program in competitiveness and innovation of the Mexican Academy of Engineering. He received a master's degree and a PhD degree from UNAM and spent 2 years as a postdoctoral fellow at IBM's Thomas J. Watson Research Center in New York. He has authored and co-authored over 800 peer-reviewed papers, is a member of the editorial board of over 50 international journals, and has received several awards in Mexico, the US, and Europe. His interests are in the area of material science and applied physics, particularly in the development of nano-sized materials for various applications, including nanomedicine and energy. He also works on ethics of research and design of public policies for science and technology. He is full professor and founding director at the Centro de Física Aplicada y Tecnología Avanzada of the UNAM, and a visiting scholar at Purdue University. His work has received over 20,000 citations and is one of the most cited Latin American scientists in this area. Professor Castaño was the first author of the article in the journal Nature published in March this year, 2024, with Pedro Fernández de Córdoba, Juan A. Sanz, and Galileo Violini, titled Big Science in Latin America, Accelerate Particles and Progress, an Advanced Light Source for Research will boost growth in the Greater Caribbean region, scientific, economic, and societal. The title of his presentation is LAMISTAD, a synchrotron for the Greater Caribbean, past, present, and future. Without further ado, I leave you with Professor Victor Castaño. Take it over, Victor.
Thank you very much. It is a pleasure and an honor to be here with you today. My recognition and gratitude to Mardabin and to Professor Gilmore for inviting me to this important seminar series, and of course to my good friend Jorge Colón for agreeing to introduce me for this conference. The idea here today is to talk very briefly about the path of synchrotrons. I won't go at any point in any technical detail, because what I intend here is to really try to arouse the interest in people for this important technology and the long-term panorama of what a synchrotron in the Greater Caribbean area could be. I will discuss also some of the very exciting work that is being done all over the world in terms of work and research related to synchrotrons. And I will spend, if you allow me, a great deal of my talk today talking about the future. None of us, I believe, are really experts in future and science, but we are all worried and concerned about the future of what we do in science in general, but in particular in the greater Caribbean. Thank you very much again for the invitation. And let me start just by reminding you that the synchrotron radiation was, according to the literature, first observed by accident in April 1947 at the General Electric laboratories in the United States. There is some discussion about the real origin of synchrotron radiation because in late 19th century, just after the discovery of X-rays themselves, there were some researchers trying to see what the effect of oscillating magnetic field will be on this newly discovered radiation at the time. Also, it is known that in the 30s, some Russian scientists were able to predict. But for any official account of the history of synchrotrons, this radiation was observed, and again, by accident, in a small synchrotron in 1947 in the United States. Ever since, in this almost 80 years, 75 years of history of synchrotrons, we have moved very, very fast and increased not only the number of synchrotrons around the world, but also we have increased the reach of the synchrotron radiation. Basically, a synchrotron is a machine that accelerates electrons at a very high energy, millions of electron volts, and then make them to change direction periodically. And this is done normally through oscillating magnets. The result is the emission of X-rays that are then directed towards a beamline next to the accelerator. And in that way, in those ports, those stations, they are able to make use of this very intense, very focused, very coherent, and very sharp, very bright beam for a number of different applications that we will be discussing. The other important thing is that the synchrotrons they were first built and reported, have produced a large number of Nobel Prizes, not only in physics, but also in chemistry. Here you have some of the more recent ones. And the Nobel Prize in Physics in 2023 was awarded to three scientists who were able to generate very, very sharp, at the level of attoseconds, pulses of light, which allowed for the first time to deduce some very fine details of different materials. There are a growing number of applications of synchrotron. If you just write in the internet synchrotron applications, you will find dozens and dozens of different applications, which are reported in thousands, literally thousands of papers. I would like to emphasize, for what I'm going to talk in the later part of today's talk, on two areas: biosciences and medical research. In biosciences, there are many applications, including protein crystallography, macromolecules, both natural and synthetic. In medical research, of course, high resolution imaging, uh, radiation for biomedical applications, the understanding of some disease mechanisms, and of course, microbiology. But you can find also papers, and we will be reviewing very quickly some of them in environmental sciences, agriculture, mineral exploitation, production of novel advanced materials, different sorts of engineering, and even forensics. Uh, because in some uh, forensic studies, you have only very, very tiny dilute amounts of samples that are impossible to study with any technique other than synchrotron. And this is basically because the most important advantage of synchrotron radiation compared to X-ray sources, like the diffractometer that you just inaugurated a few days ago, and which I congratulate for to all the University of West Indies, but in particular to Marbadine and to Dr. Gilmore for being able to have this facility there. But that doesn't prevent us from using synchrotron radiation because synchrotron radiation has millions of times higher brilliance, and that allows not only to have a unique resolution annotated with any other technique, but also to use, as I did mention with the forensic samples, information, very valuable quantitative information from very, very tiny samples. In this almost 80 years of history of synchrotrons, the presence of Latin Americans and people from the Caribbean is being recorded. We are fortunate to have many scientists in Latin America and the Caribbean who work and are considered experts in synchrotrons. Here you can see a book published by El Colegio Nacional, the National College, one of the most important as academic institutions in Mexico, a few years ago, about the possibility of establishing a synchrotron in Mexico. Also, about 7 years ago, there was this meeting organized by this organization, Light Sources for Africa, the Americas, Asia, Middle East, and Pacific, in which many professors and scientists from the area, including our good friend Abel Moreno, who's second from the left in this picture, were able to begin discussing the possibility of having another synchrotron machine in Latin America other than the one existing in Brazil. Then, 3 years ago, we produced this paper, which you can find in Archive, in which people from Guatemala, Colombia, El Salvador began to wonder how we could organize this isolated effort from Mexico, from Colombia, from other Latin American countries to construct a regional effort rather than a specific effort from a given country to see if we could be able to share not only the cost, but also share the benefits. And I will go back to that in a few minutes of having an extra machine of this type in the region. Then, about a year and a half ago, Galileo Violini, who's an important part of this project and is being an important leader for all the efforts towards constructing this regional facility, wrote this article on the publication of the Società Italiana di Fisica, talking about this project LAMISTAD. LAMISTAD stands from Latin American International Synchrotron for Technology, Analysis, and Development. This was, as Galileo Violini states in this paper and other publications that he has presented, that was an independent, by no means a new idea. For almost 10 years by the time, there were efforts and proposals in Colombia, in Mexico, a couple of colleagues, Brenda Malderrábano, Victor del Rio, Matias Moreno, Abel Moreno, another distinguished Mexican scientist, attempted in the early 2010s to convince the local government of the state of Morelos first, and then the state of Hidalgo, to allocate the land and the resources for this. One of the problems that you can imagine, and we will be discussing that later on today, is that we need more than scientific reasons and scientific arguments to convince politicians to be able to decide to work in things like this. Also, after Obama's visit in 2016, there was a possibility of having also a synchrotron in Cuba, which was more within the Caribbean area than the other efforts in Colombia and in Mexico and in other countries, with the son of Fidel Castro Smirnov. But for a number of reasons, including pandemics and also the death of Fidel Castro Smirnov a few years later, this was basically suspended. And to my knowledge, this has developed no further. We also have been working as a group, including distinguished persons like Marbadin, Jorge Colõn, and a group of around 50 scientists from all over the world, mainly Latin America, but also people from Italy, from France, from Spain, of course, working towards producing more than a project, an effort, organized effort. And in this way, we have participated in various symposiums in the Dominican Republic. We have also, as a group, being able to contact large groups of people either owning or being responsible as synchrotron, or at least being standard users of these things. As Jorge said, as a result of this effort, in March of this year, Nature published a paper authored by Leo Violini, Pedro Fernandez Córdoba, and Juan Sainz, who are professors at the Universidad Politécnica de Valencia, and myself, about how big science could accelerate not only particles and produce bright light sources, but also produce bright ideas, innovative ideas, and accelerate the development of the region. As for today, we have around roughly 70 something synchrotrons around the world. In Latin America, The only one is in Brazil, but you can see that many areas of the world have access to this type of facilities. The other thing that I want to emphasize is that since almost the original development of synchrotrons, people was interested in what was the practical application of this very big investment. We are talking about hundreds of millions of dollars for industry. I mean, for people who work in science, this is a fabulous piece of equipment. But how a government could convince industry and society to really decide to invest in this type of facility? And even one of the most important facilities in the world, Brookhaven National Laboratory, in 1987, was trying to see how these technologies, originally developed for high energy physics, could be transferred to industry. We know today that the synchrotron radiation is a very important ally of material science. And as you know, materials is one of the most active areas, not only in research, but also in development. Uh, Roughly 80% of the materials that we use today were invented less than 100 years ago. We really truly live in the era of new material. As I did mention before, uh, people are finding more and more applications of synchrotron radiation to problems like environmental challenges, which is one of the main concerns of the world today. Also, how synchrotron radiation could be employed to deduce the calcification process of different marine uh, structures and how plankton could record climate change. This is a relatively recent article, and we have been doing some work along this area as well. I did mention that to Professor Gilmore. Uh, Synchrotron is also finding ways to study fossil energy deposits, effects, and perspective, as you can see in this paper. There is a very interesting organization. It's called lightsources.org, which I recommend you to take a look. It's been around for 20 years, and it is concerned with all type of light sources, including, of course, synchrotrons. But I want to point out here is that they are recruiting people for different applications, different jobs related to light sources, and I put them at the bottom. Today, synchrotrons require not only physicists and experts in engineering, but as you can see here, administrators, electronics, different type of engineers, human resources experts, marketing, students, postdocs, procurement, safety, management of all sorts, of course, software, artificial intelligence, and so on and so forth. So what I'm trying to stress out here is that the synchrotrons are a source of jobs and a source of careers for most of careers that we teach in our university, not exclusively physics. Let me now focus a little on how has been the effect of synchrotrons in developing countries. And this is a recent article about 2 years ago by a German group of researchers who are heavily involved in sesame. This light source in the Middle East, which has been around and producing a very interesting outcome, not only in terms of research, but also in terms of regional effects. For example, in in Sesame, they have developed some applications that are of region, which are of regional relevance, including life science, material science, environmental science, and of course, given that the area is to very much extent the cradle of civilization, Western civilization at least, uh, the application of this technology for cultural and archaeological objects, which are very delicate, unique, and we cannot uh, have the chance to lose a tiny piece of this, uh, has been successfully used in sesame. Uh, in Africa, also, there's a strong interest and very active group of distinguished scientists from this continent working in, in with synchrotron radiation, in particular in biology and energy material, which are, of course, two important areas for research and development, but also in many other applications that are summarized in this recent article. Uh, for the Brazilian case, which is for today the only Latin American country that counts with a synchrotron, there has been also important impacts for industry and innovation using synchrotron to the extent that they are building a new light source, and that will open the possibility of collaborating with them, but also to justify the need of more uh, of these facilities in the region. Just briefly to let you know, this is a plot of the amount of additive manufacturing part, that is 3D printing part, uh, as for 2021. And you can see there is an exponential growth. And to no one's surprise, synchrotron is also finding a place for additive manufacturing processes. Also, the instrumentation of this very detailed processing of novel materials and novel devices can be helped by synchrotron. Now, let me move from what we are doing today with synchrotrons in the world, which is, as you see, exciting, to the future. And I guess you will agree that the future, not only of our countries, but a good deal of the world, lies in the Caribbean. Mexico is also a Caribbean country, as you will see in a minute. And the World Bank agrees that the Caribbean has a very significant economic impact and very high growth opportunities, as we shall see. But there is also some vulnerabilities that we have to work with. Just to remind you, there are different Caribbeans when we use the word. Of course, there is the insular Caribbean, which comprises all the islands of the Caribbean region. But also we have a Spanish Caribbean, Spanish-speaking Caribbean, Cuba, Dominican Republic, Puerto Rico, parts of Mexico, all of Central America, and parts of Colombia and Venezuela. And if you include all the regions that are in terms of culture, climate, biological resources, and everything, we can talk about El Gran Caribe, the Greater Caribbean, which includes all of this, but also the southern part of the United States, part of Texas, Louisiana, and of course, Florida. So this is a very unique region in terms of the diversity, in terms of the richness and the resources that we could obtain. To the extent that the World Economic Forum uh, published in 2021 uh, a study, a very interesting study that I recommend you to take a look to, and probably you are aware of this document, which are related to how we have to construct economic institutions for a resilient Caribbean. Uh, and this uh, study published last year uh, poses different scenarios for Latin America and particular the Caribbean up to the year 2030. There are three big global questions. What will global growth look like in general, and how this will affect the region in terms of trade and development globally, and how this very imbalance, to use this term, uh, world that we are living at with conflicts in different parts of the world will represent either an opportunity or an extra problem for the Caribbean region. Here you have the expected growth of the economics of the different areas. Uh, of course, the Asia and the East, China, Singapore, South Korea, and so on and so forth, are leading this. The United States is following close together. But if you combine the economic growth of the United States with that of Latin America and the Caribbean, you can almost match that of the Asia East region. That is, we are losing opportunities as a region that, again, as I said, includes part of the United States, which have the same culture, the same in many cases, like in Texas and Florida, the same language that we speak in many Latin American countries. There are different scenarios. The scenario number one is modeling through. There is a well-known problem between the United States and China, and we, as a region, could either be spectators of this or play a role. The second scenario is governance and the growth of crime. I'm not just talking about explicit crime, but also cybercrime. Artificial intelligence is wonderful, of course, but as Jorge Colõn said, I'm also interested in the ethical development of science, and in particular, the ethical problems posed by artificial intelligence. 3 weeks ago, we organized here in Querétaro, where I live in central Mexico, international symposium. We expected around 200 participants, and we had over 800 participants, showing the importance of this area. And the title of this symposium was Neurosciences, Artificial Intelligence, and Law. And this lies within this second scenario. The third scenario is how we are going to cope with these first two scenarios. Integrating ourselves or keeping fragmented, as we are pretty much. We need to find regional projects in which all the particular interests of every single country of the region is fulfilled, but also keeping in mind the needs, the goals, and the characteristics of the other ones. According to ECLAC, uh, in this coming years, there will be a slow growth of the Caribbean due to many reasons, the COVID among them, but also the differences and the lack of integration that we have. The World Academy of Sciences agrees that it is important to invest in the Caribbean future, not only for the region itself, but for, as we will see, for many of the interests that we have as a world altogether. Let me show you briefly, yeah, moving towards the end of my presentation, this article 4 years ago in the uh, Cuban Review Journal of Information in Health Sciences. And what's interesting is that they made a comparative study between Cuba, Jamaica, and Trinidad Tobago on how people in these three countries is working in science. And what they found is that the people, researchers in these areas are very focused towards uh, medical sciences, biological sciences, and natural sciences, and of course, social sciences. Engineering and technology is not that well developed, which of course is to no one's surprise. But what I would like to both present here to you today is that this could be an opportunity. And let me elaborate a little more on that. In the world, in 2014, a study showed that these gender differences in science has some peculiarities that we should attend. If you look at, for example, social sciences, you will see that there is a very high women's participation. Also in biosciences, which reflects, again, this Cuban study that I just mentioned to you. So, but worldwide, this is a trend. Women are attracted to social sciences and bioscience. In engineering, physics, computer sciences, and economics, the participation is much lower, according to this study by the National Science Foundation. But on the other hand, we see that the participation of women in the last 10 years is been growing significantly. I mean, almost doubling the size. So women, despite of the problems, are interested in science, but unfortunately, not the type of science that in principle will be related to a synchrotron. This study shows that there are three dimensions of the development in Latin America. One is the social dimension. This year is the year of mankind's history with the highest number of elections. And in particular, in our region, starting from my country, Mexico, we have 6 countries that have presidential elections. And by the way, we elected last June not only the first female president of Mexico, but the first female president of North America, including the United States and Canada. There's an economic dimension. The growth of this area in our countries is going to be important, and a little above the growth that is expected in other areas of the globe. Just let me show you. Let me show you a little thing here. I don't know what happened, but
Can you click on your slide 48 if you want to talk about it?
yeah. Let me see. What happened is that my screen got black.
Oh,
Let me see. I don't know what happened. Apparently, there was a little power failure here,
oh, I see. Yeah.
and I cannot see my own screen. I know I'm still connected.
We're seeing
Okay.
your last slide that has all your contact information.
Okay, let me
That's
move.
There was only the previous slide was the one that we couldn't see, but that's fine.
Okay, let me just give me a minute and I show you, because for some reason, apparently there was a problem with my screen and I don't see it. Just give me a minute. Here it is. Okay, I'm sorry. So, and the third concern is the environmental dimension. There is a big climate change, but we also note that this climate change is affecting the Caribbean for a number of geographical reasons. This is finally an interesting uh, position that I would like to share with you. This is the gender gap score all over the world. What it means is that there is a score reflecting how many years will a region in the world will require to achieve gender parity. The worst case is South Asia, which will require 195 years to achieve gender parity. But even Europe is 52 years away from achieving truly gender parity. Latin America is 69, which is not that far from the rest of North America, including Canada, the United States, and Mexico. So what I'm trying to say is that this is an opportunity not only for science growth, for economic growth, but also if we are able to uh, add some gender uh, uh, bias or some gender character to our proposals towards the uh, uh, synchrotron in the Caribbean, we will be able to also attract women who are already interested in biology, chemistry, social sciences to these more physics-like areas like synchrotrons. So the the end of the story is that we I personally believe, and I think this is shared by many of my friends and co-workers in this uh, LAMISTAD project, including Marvedine, including Jorge Colõn, of course, Leo Violini, and many other friends who are here with us today. Uh, we have an opportunity to boost the science of the region, to boost the economy of the region. As I said, synchrotron includes many jobs in whatever specialty you could think of. But also, and I will end with this, have an opportunity for women in our area. This creativity, this hard work of greater Caribbean women could find a good crucible in this synchrotron in the region. Thank you very much. and I would like very much to keep in touch with you and to answer any questions or to share any comments with you. Thank you.
Very good, very good. Thank you, Victor. I think that you did an excellent presentation about the development of and the history of synchrotrons, their broad range of applications, the initial efforts that had been occurring in the Caribbean region, and how it's only through regional collaboration that we hopefully will be able to advancing our goal of having a synchrotron facility in the Greater Caribbean, and how that will benefit and advance the economic and social development of this area. So I would like to open the floor for questions. So let's see, you may raise your hand or open your mic, and we're ready for questions for Victor or comments. Who want to start?
Jorge, it's Kayla from Puerto Rico.
Kayla, oh yeah, go ahead.
Excellent presentation, Victor. I have a question. Information about the participation of the woman in
Kayla, thank you very much for your question. And the only thing I heard was that you were congratulating me for the presentation, which I appreciate. And I believe your second question, your question was really about the participation of women in synchrotrons. While preparing this presentation for almost 2 months, I did some research and found that there is very scarce information about that. However, what I can tell you is that first, there is a growing number of female scientists interested in synchrotrons in the last perhaps 5 to 6 years. You can find some very distinguished females holding important responsibility positions in some of the main synchrotrons around the world, which is fantastic, but also an increasing number of women. The second thing I want to mention is that I asked myself the same question that you're asking. And as a result, I convinced one of my students, who's a physics student, is a young lady, to do some work by using big data analysis, artificial intelligence. And if at some point you are interested, we would like very much to do this work together, because that will improve and make stronger my claim that in addition to all the advantages that an synchrotron has, it could be also an argument for diminishing gender bias.
Thank you, Victor.
Thank you.
Thank you, Kayla. Anybody else with a question or comment? Let me just mention and add to the discussion about gender parity, which is so important, that also it'd be interested to see how more students, users of these facilities, how the number of women might have been increasing. For example, just to mention, in our collaboration with CHESS, the Cornell High Energy Synchrotron Source, in our NSF program, we have had a number of women and female students using those facilities and visiting CHESS to learn about the science. So it'd be interesting to have also the students' statistics who had participated in different synchrotron facilities. So any other one with a question or comment or suggestion?
There's one from here.
Yes, there's Roberto Flores Castillo. There he is. Yes, please. You can open your mic.
Okay, thank you.
Yes.
Thank you. So I would like to ask you, you mentioned that there's this effort on the whole Caribbean region. Now, do you know of if there are some current efforts trying to get funding or trying to organize the construction or trying to push a proposal to actually put together an organization of several governments to do it? I mean, what is it? I know that Victor del Rio somewhat recently was working with some people to try to make a presentation in the United Nations. And I think that there was a presentation over there. But I don't know, I haven't followed it after that. So can you comment on whether there are some current efforts in that direction?
Yes, as you mentioned, Victor del Rio was very, very active in convincing and talking to different state governments in Mexico. And at some point, it seemed almost a fact that the state of Hidalgo was going to make the decision. Unfortunately, for a number of reasons, both political and economical, this was not done. And last year, Victor Rodrigo organized a presentation as a satellite meeting in the General Assembly of the United Nations in New York. I participated there as well. And in the last few days, uh, Leo is trying to organize exactly the idea that you are mentioning, how we can put together not a single government, which seems to be not a very effective strategy, but a regional effort. So the long answer to your question is that we have thought about that, we are working about that, but it is still a work in progress.
Yeah, and
Okay, thank you.
I would add, Victor, that that's precisely what the Greater Caribbean Light Source and LAMISTAD effort is trying to do, right? How to gather those efforts to see if we can get governments and wide support to this initiative. So good, very good. So anybody else with a question or comment in the last few minutes that we have left?
Yes, Prof. Colõn.
Yes, please, of course. Go ahead. Everything. Yes.
That's me.
Yes, please, go ahead.
Morning, everybody. It's still morning here in Jamaica. I'm saying a few things and then I'm gonna call on somebody. I'm putting him on the spot. Let me just say that today we're having a series of events started at 7 a.m. this morning, organized by the members of the team. And this morning we did have a number of people involved in policy making from Ghana and Kenya as part of this UNGA session. And that Lawrence really has been instrumental in organizing. So, and we also shared over here in the Caribbean, we shared what's going on, I've spoken to the Minister of Foreign Affairs here, but she's still in New York, I think. So there is some move toward that engagement. Science, not just for science, science for society, science for diplomacy, and the diplomacy for science is ongoing and a mission of the team. Let me also say that we have a survey running, and if you look on the survey, have you ever heard of synchrotrons? 107 people have responded from all over, and most people have, 71% have. The people who are responding, only 33% of them are females. But what is interesting actually is that 92% of the people would like to know more. They've heard about it, but they don't know much. And so at this point, Professor Sekazi Mitingwa is here. And I'm going to call on Sekazi because Sekazi is chairing LAMP. And LAMP has the faculty and the student team program, the FAST team program, that will send faculty member and student to visit a synchrotron. My student and I got that chance in 2019. Out of that came this new effort to build feeder facilities and expose our researchers and our scientists in the region to feeder facilities like X-ray diffraction. So crystal is a realization of this capacity building that's needed to get us there. Sekazi has told me that the Caribbean does not have many applicants. And the deadline coming up for 2025, so Kazi, please tell us some more.
Well, yes, just as Marvadine stated, the LAMP program has this, the LAMP organization has this program where we send a faculty and a faculty's graduate student to one of 17 light sources around the world where they can train for 2 months. And in the future, they can go back in another year for 2 months. But yeah, the deadline is October 31st. So if you go to the website, I just in fact put the website of a description of crystallography and synchrotrons in the chat. And so if you go to that website, you can go to the homepage and it will direct you off to the FAST team program under calls. There's a button that says calls and you can apply. But we definitely need to have more applications from Latin America. Last year, there was almost none, which was unusual. I mean, in the past, we've sent a number of faculty student teams from Latin America. So I don't know what happened last year, but please go to the website there and um, either apply yourself or encourage your faculty colleagues to apply for that program. Thank you.
Thank you so much, Sakasi. I must say that I don't see the link that you placed in the chat. Did you hit the enter?
Yeah, I did. I see it came up.
Okay.
I don't know why you don't see it. Do other people see it?
For some reason.
No, I don't see it either. Maybe you sent it instead to everyone, to some particular person. Maybe you were in.
Yeah.
Oh, that's no problem. Oh, I'm sorry. I sent it.
Okay.
Make sure it's to everyone.
Okay. Yeah. I have to send it to her. Yeah. I don't know.
Yeah,
why.
I see now. Thank you, Sekasi. I see now that Luis DeBev has his hand up. So, Luis, please.
Yeah, just a quick note. I'm Luis DeBev. I'm a scientist at a synchrotron at Chess. And so for anyone, I just want to recommend for anyone who's interested in this LAMP program, it's always a good idea to contact someone at a synchrotron, and discuss this in advance, especially someone who is able to come with their own funding. Can be very interesting. So I encourage you all to talk to scientists if that's something that you're interested in.
Yeah, as a part of applying for the FAST team program, if you go through the instructions, you have to make contact with a beamline scientist at a light source. You don't just apply. I mean, you have to actually do some legwork, apply, make a contact, and that person has to accept you as a visitor, as a user. Thank you.
Thank you, Luis. That's a good idea. And Sekasi, we see the link now. So thanks a lot.
Great.
Jorge, before Lawrence comes in, can I just say that for those of us in the Caribbean, in the islands, we have a strong relationship with Brookhaven National Lab, BNL. Some of our people do the course, some of our people have been going. So you can let me know if you're interested, and we can, Kun, who heads that, is one of the directors there, works very closely with us. Okay?
Thank you. Yes, we also opened that same idea about collaborating and sharing information for anybody interested in going to Chess. I see a comment here, but again, we reach it's 1:03 p.m. I guess we're about to finish. So I would like, first of all, thank again Victor Castaño for an excellent presentation. And I'll also thank everybody who came here to join us in this discussion.
Lawrence Norris has his hand up, I believe. Of Colõn.
Yes.
Lawrence Norris has his hand up.
Okay, let's have him.
Please. Hi, so I did put a link in the chat. There is a student at University of Puerto Rico. I just found this online like a week or so ago. She's I guess Jorge, you may know her, right? This is your student?
She's my grad student. Yeah, she's my PhD student.
So you can read her profile, very interesting.
Thank you.
Just a fascinating story. And
she's involved in this high magnetic field X-ray beamline project that's being currently happening at Chess. That is building a new facility, a new beamline there. Yep. That is going to be open to the general public in January 1st, 2026. So she has been heavily involved in that project. So we're very excited about that. Thank you, Lawrence, for pointing that out.
Yeah, in fact, I see Joe Brock, who is here, so it's good to
Right.
acknowledge him. He's the director of chess. So
He is definitely. He's our co-PI of our NSF Prime program. Yes.
great.
Thanks for being here, Joel.
Yeah. And so I'll just end there. I mean, most of what I have to say, we'll probably write up in some article somewhere. But I just wanted to point out this student because it's a very fascinating story. And I looked up her paper and very fascinating work.
Thank you. Thank you so much, Lawrence. Okay. Just want to make sure that anybody else have a final comments, because we're about to wrap up. If not, Professor Galmore, you can take it over. Thanks, everybody. Thanks, everybody.
Okay. Thank you very much. I just want to use this opportunity to thank you all for coming online. It's the whole Caribbean, Latin American feeling is really amazing. And it's good that we'll have this potential collaboration and that we are, of course, very optimistic that things will go well. Thank you very much, Prof. Colõn. Thank you very much, Prof. Castaño. Have yourselves a wonderful rest of the day. And for the other session that's coming up, I trust that you will enjoy that as well. It's at 1 p.m. Jamaica time. All right. Thank you.
Bye-bye, everybody.
Bye-bye, guys. Thank you.
Te veo, Víctor. Cuídate.